Good evening, everyone. So in the last session, we identified the one of the important example on this particular tree set here. So how it is working internally, this particular tree set. Tree set basically it is trying to use comparator or the comparable. If you are not using this particular comparator, it will try to implement this particular comparable here. Okay, this is important. We need to understand. And using this particular comparable, we are trying to sort the order here. Okay, so how we identify this example? Now you can see I'm trying to creating this particular the root object here, something like 89, and the root object internally it is contain this particular 45, and 45 internally would contain something like 12, and here we are going to have something like 54, and 54 internally 54 internally it is having this particular right side value something like 56 here. Okay, same way here we are going to have 96 internally. Okay, 96 internally, what exactly it is containing here? 96 internally it is having right side value something like 1 2 3. This is the entry record we created. So this is, we can call it as a our root object here, and this is, we can call it as a left here, and this side we are going to call it as a right. So these are all the entry record we created internally. Okay, now observe carefully what exactly I'm doing here. Again, this is having same right side and left side, and inside this particular right side this is having same right side here, and the left side we are having null values, and this particular 12 one right and left both are having null here. Both are having null. So this is important, we need to understand. And 96 also internally it is trying to connect with this particular right side. Okay, internally it is connecting this right side. So 1 2 3 here the left hand null and right side also we are having null only. Both are having null. This is the entry record we created internally inside this particular tree set. Okay, so if I'm going to run this, so this is only the way we are going to get. And finally, now what I'm doing here, I'm trying to print this particular iterator. So what exactly this iterator is doing here? And iterator dot next method I'm calling. Getting the pen. So before going to call this particular next method, first I will print this particular while here. Using this particular iterator dot, first we'll go for the has next, and later we'll call this particular iterator dot next value. Okay, now we'll identify this particular next how it is going to print this. This is one of the important example we need to understand here how this particular iterator is implemented. Now I'm putting the breakpoint at line number 18. I'm going to run this particular example. So observe carefully, we are running on the same example what we discussed in the last session. So observe carefully, I'm calling the add method. So add method is trying to insert this particular record with help of this particular entry. Okay, finally I'm calling this particular iterator. Now whenever I'm trying to call this, it is calling the navigable set getting pens m dot navigable key set. Navigable key set it is calling. So yesterday whatever we discussed this particular linked list here, whatever we discuss the linked hash set, it is trying to call on the key set. Now what about this particular method we are calling navigable key set? Okay, now I'm trying to show you this particular navigable key set. So whatever this particular navigable key set we are getting as a null. Whenever we are getting as a null, what I'm doing here, if it is in case not equals to null, it will return this, otherwise it will move on to this particular key set. Okay, it will move on to this particular key set. So here we are passing key set dot this constructor. Internally, navigable internally, it is trying to work on the key set only. So finally, I'm calling this particular iterator. So if you see, whenever we are calling this iterator, so this is the class it's calling internally key set e, and internally it is trying to extending this particular abstract set. Okay, and it is implementing this particular navigable set interface here. So now what I'm doing here, I'm trying to override this particular iterator method, and we implemented this particular code. So what is the M right now? M basically it is a tree map only. Okay, internally it is a tree map. If you see, these are all the 6 records we are having. If I'm going to expand this key value, this 12 one and 45, 54 and 56, something like 89, 96 and 123. Getting the point. So this is the order we are getting. How I am getting this particular M here? We need to understand this particular M wherever we are using this M. So now if I'm going to, so case sensitive whole word, if I'm going to find this, here we are having this particular M record. But here what we need to understand, where this particular M is initializing the value. Getting the point, where this particular M is initializing the value. So now I'm trying to providing. Now you can see this is the tree map we created, where we created inside this particular navigable submap. Okay, this is the one more abstract class we are having inside the tree map. So we are created inside this particular tree map lot of nested classes. Okay, lot of nested classes we created, and one of this particular nested class navigable submap, and internally it is extending abstract map here. Okay, so this is the M we are having here, and internally where we are initializing this. So this is the parameter. Okay, here we are passing parameter, like it is a one of the constructor of this particular navigable submap we are calling, and we are passing this. Okay, after this, so comparing we are calling, and here also we are comparing, and we are inserting this. Okay, after this we are comparing, getting the point. So these are all the compare related method we are having. Okay, these are all the compare related. But when we are discussing this M, from where it is coming here, whenever we are calling, whenever we are trying to discuss about this constructor here. Okay, this constructor where it is, yeah, this constructor from where we are calling, this is important here. From where we are calling this particular constructor, we need to identify. Now you can see, so this is the navigable map dot, this comparator we are calling, but not this. So we are extending this class, and here also we are extending, and here also we are trying to make as a some type here. Okay, so finally we are trying to check this. Okay, this is one of the important example we need to understand from where this method is called, like sorry, constructor is calling it. So can you mute yourself who is joining you? Okay, so observe carefully. Now this is the tree map dot navigable map, and we are passing this M here. Getting the point. If this particular iterator, this is not a map here, this is not a tree map, we are calling this particular section, the M we are trying to converting into the navigable dot submap. For example, if I'm going to copy this particular M from beginning onwards, we need to identify. So these are all the different we are having. Put all method and sorted map, it's a constructor we are having, and directly we are passing to this M. Okay, finally what we can understand here, this is the one of the variable they defined, navigable map, and from where we are setting, this is important here. Here we are not checking this, we are not inserting the value. These are all the values written lowercase, something first last key, comparator, remove, submap, head map, tail map, descending, and key split iterator. Okay, so finally now we are backing into this particular tree map. So okay, anyway, now what we need to understand here, we need to understand very carefully, because of this particular M, we are getting all the records. Now we are trying to checking the instance of, now it is converting this key iterator. Okay, key iterator it is trying to converting. If I'm going to call this particular key iterator, now what I'm trying to pass here, key iterator dot get to first entry. Getting the point? We are calling get first entry. So if I'm going to call this particular get first entry, so this is the root we are having. Okay, what is the root we are having? 89.45. Now, if we observe carefully, whenever we are calling the toString, if you say this, so this is the, sorry, it is the iterator we are calling. The same iterator internally, it is called from the toString method. Now, what you understanding, whenever I'm calling this particular iterator, so it is calling this treeset.iterator, and internally we are calling this particular tree map, and we are calling the same key iterator class here, and we are calling the get first record. So how I'm checking it? If I want to load this particular first record, this is the way of loading this. So p not equals null, because this is the root object. Okay, so 89. So now you can see here we are having the same 89 here. So just now I discussed it. This is the root record. Same 89 we are getting. After this, p dot left. So what is the p dot left? P dot left we are going to get as a 45. Okay, 45 will get here. Now you can see 45 I am getting. And after getting the 45, we are trying to set into this particular p. Now you can see. So now the parent, or we can call it as a p value 45. Again, the p dot left. The p dot left, what is the value we are having? Here now you can see 12. Getting the point. So 12 we are having. So this is the smallest value. But how we are loading this? First we are loading the left side value. Later we are trying to load the right side value. So if you see carefully, this section is a less value, like smallest value we are stored here, and this section we store the some bigger value. So now using these two sections here, we are trying to print lowest to highest here. Lowest to highest. So this is the get first entry record is showing the information. Observe, so p dot left. P dot left, what we are trying to return here? Something like 12. So if this particular 12 we are going to get, now I am trying to set into this particular p is equals to p dot left. Finally, this 12 cannot have any left or right here. So that is one we are getting as a null. Now you can see. So finally we are at this particular 12. We are at this particular 12. So this particular 12 left side and the right side both we are having null here. So here I made as a null records. Now, so this is the main important information we need to understand how this particular iterator it is calling internally. Okay, now you can see, because whenever we are calling this, so if it is coming out of this particular section, we'll return this particular p. What is the p we are going to return here? The p we are going to return as a the p we are going to return as a 12.58. So this is the smallest value. Okay, the 12.58 is the smallest value. Now I am calling this first record, and I'm trying to set into this particular key iterator. Whenever I'm trying to set, it is a constructor I'm calling. What is the first record I'm setting here? Getting the point. This is important here. We are trying to call this particular constructor to set the record here. Now you can see what is the first record I'm passing. I think it is not showing, but whatever the 12 dot, the 58 something we have the first record I'm trying to set here. And when you are calling this internally, it will call next entry, and it will print this particular key value. Okay, whenever we are calling this particular next. Okay, this is important here. But first now what we are doing is we are trying to call the iterator. So this is returning the iterator. Now we are coming back to the iterator object here. So iterator, it is loaded by default the first record. So after loading this, now we are checking the has next. Now we are checking the has next here. So I'm not going to check this. Directly we'll move on to this particular method, how it is implemented internally. Now you can see directly tree map. So what is the next we are having? What is the next we are having? 12.58. So where we insert this particular next here, we insert inside this particular the key iterator. Get in the point? Because this is the one of the abstract class we are calling it, and this abstract class internally it is extended from the key iterator, something whatever the key iterator we identified here. So let me copy this. I will show you where we shown the code. Now you can see this is the one of the entry iterator we are having, and this is the value iterator we are having, and another one key iterator. Now you can see the key iterator internally it is extending from this particular private entry iterator. Okay, private entry iterator here. So now right now we are calling on the has next. Has next is where it is implemented inside this particular one of the abstract class. Okay, next method is implemented in the specific classes, but Getting the point? This particular, see the root basically, so if I want to show you the root, again we need to discuss this particular example. So whatever we discussed in the last session, that is important to the way of executing the one by one. Now it is modified to the 89 year. Okay, so we'll see how it is implemented the root record later, but focus on now the has next. Has next where we implemented one of the abstract class called private entry iterator. It is implementing the iterator section. Okay, and this abstract class is extended from the, these are all the classes. The first one is, here now you can see entry iterator is a one class. It is extending from this particular private entry iterator. So now value iterator is a one more class. It is extending this, and key iterator. So here we are going to call this particular next method. Internally it will call this particular next entry dot key. Okay, where we implemented this particular next entry. So that we need to see, this is the previous entry, this is the next entry. Okay, this is the next entry record. So whenever we are executing this particular next entry, it will return this. But by default, we are trying to load the first record. How we are loading the first record? So the key iterator we identified whenever we are trying to create the constructor of this particular object here. Not this, so this one, key iterator. So this is little bit clumsy, but if I'm trying to provide multiple time, we can easily understand. So first, what I'm doing here, I'm trying to clear this particular diagram. This is very important diagram we are discussing. First, what we are doing internally, we are trying to load the left side records. Okay, so this is the root object we are having. So first we are loading the left side. Later we are trying to load the right side information. Okay, because of this particular first record, we are loading the left side, and if the left is contained some other left records, which will try to identify it here. Okay, now back to here. Now back to here, what we need to understand here, we are at this particular has next. The next we are having, so this particular next here. So how this next is implemented? How this particular next is implemented? If I'm going to show you the key iterator, what I'm doing here, I'm calling the super constructor by passing this particular first. Okay, super constructor, how we are going to call, because this is extending from the private entry iterator. So where we define this private entry iterator, this is the, okay, this is the private entry iterator. Now we are calling this particular constructor. So we are passing this particular first record, and internally it is trying to store like this. Okay, this is important here. Now what I'm doing here, I'm calling the has next method. I'm calling this particular has next method. So this is returning the next. So this is important here. Few of the methods are implemented in the private entry iterator, and the specific methods are implemented inside the specific class. What are the specific classes we are having? I will give you the diagram. First, now you can see this is the iterator is implement like interface here. It is implemented by one of the abstract class called private entry iterator. So I'm trying to write the shortcuts here like PEI, private entry iterator. This is the abstract class. This abstract class is extended by multiple classes. The particular multiple classes I'm trying to write these three. Okay, first one is entry iterator, and second one is value iterator, and third one is key iterator. Now if you see here, this is an abstract class. Okay, it is implementing this particular iterator. So as of now, these two we identified. Okay, these two identify. Iterator is the one of the interface. It is containing like how many methods we are having inside this. If I'm going to show you, like has next and next and remove method. So this is the default method. If you are overriding this remove method, it will work. Otherwise, it will call this particular remove method. And any other method, this is the for each remaining. So one more default method is available. But focus more focus mainly these two methods. Next has next method. Okay. We will focus more on this particular has next and next. Later we'll see the default method. Now observe, this is the one of the interface. So I'm going back to this. So we discussed this iterator. It is having mainly two abstract method we need to override. So the one abstract method, Okay, the one abstract method is override here, has next. And where is another method, next method? The next method, if you see, this, here I'm going to provide. Now you can see entry iterator is a one class, so something like this, and it is extending private entry iterator. Okay, here you can see PEI. So PEI stands for private entry iterator. So one class, and here we are trying to extending this particular, like we are trying to implementing the next method. So some method we override in the abstract class, some of the method we are overriding inside the specific class. So here we are overriding something like has next. Okay, here we are overriding next. Now finally, whatever the abstract method we are having, the two abstract method we override inside this particular classes. So this is the one class we are having now. So one more class. So this is we discussed entry iterator, and another one value iterator. Inside the value also we are trying to override next. Okay, and finally we are having key iterator. So this particular key also it's overriding next. So now what you understand here, this v also is overriding the next method. Okay, and this particular key also overriding the next method. Has next, it is implemented in the abstract class, and the next method is implemented in the these three classes. So this is the iterator is implemented inside this particular three classes. These are all the three very important classes we have right now. Okay, so finally now we identify. Now I'm going back to the wherever we are having. So we are calling the has next. How we are getting this particular next here? Because internally we are calling this constructor. From where we are calling this particular constructor? We call from this particular constructor this. Okay, this particular line, the 125 by 2 1260, we call the constructor. Okay, I will show you one more time this example. Now observe carefully. Let me go back this particular has next. So has next we are having next record is not equals to null. Because of that we are not getting any like false value. So this particular has next is returning true because we are inside the while loop. So this has next is returns true. Whenever it is returns true, we enter into this particular system.out.println and we are calling itr.next. Okay. Now, if I'm going to call this particular next, where it will go? It will go to the particular, what we can call it as a key iterator. Now, I'm trying to move on to the next method. Now you can see we are now inside the key iterator. Okay, we are now inside this particular key iterator. Now it is calling next entry. Where we implemented this particular next entry? So carefully observe, this next entry is implemented inside this particular one of the abstract class. So you can see this is an abstract class we are having, private entry. So this is the scope we are having. So see 1237, the scope is ended. And if I'm going to show you here, they implemented this 1203, 12032, 12. This is the code. Okay, 1212. This is the next entry is implemented inside the one of the abstract class. Okay, now I'm going to call the same method. Now observe carefully. Now we are at so like 1204. 1204. So what is the next we are having? So we are having 12.58. 12.58. Right. So after this, if this particular next is null, we are throwing an exception. But in our case, it is not a null. So this particular condition is also not going to throw any exception. So finally, which method we are calling? This is the successor method we are calling. And if I'm going to show you this, now we need to understand. So what is the T basically? It is the 12 related record we are passing. Because this is the first record. Okay, this is the first record we are passing. After this, now what I'm doing here? Now you can see we are checking the right side value. 12 dot right. So because the 12 dot, it does not contain any left and right value. The right is null. Getting the point? Because this is only the smallest value. Now if it is null, we are checking into this part. Okay, now you can see I am checking the parent. So I'm checking the parent. So I will give you the same diagram one more time so that we'll understand how it is implemented. So as we discuss here, 89 is our root node. Okay, and here we are having something like a 45 as a L, and 96 we are having as a right here. R I'm trying to define. So left and right. So 45 again it is containing left and right. So the left most probably I hope it is 12 and it is 54 or 56 something, I could not remember the value, but it is containing some value like this. So this is the R value and left we are having null. Okay, and this is the 54. So for this 12 we don't have any, both records are null, left and right. So just now we discussed this, so this is completed and this is the right side for this particular 45. After this we are going to have only one right side value, something like 1 2 3. Okay, this is the right side value. Left side we are having null. Okay, this is important. Now finally observe carefully, t dot parent. What is the t value we are having right now? What is the t value I'm having right now? T is a 12. So where we are in right now? 12. So this is the record we are trying to load, 12 record. Now what is the parent here? Getting the point. What is the parent basically? 45. So if you see, if I'm going to load this parent, what I'm getting? 45, because this diagram also is giving the same information. So 12 is connected with this particular 45. Okay, 12 now it is connected with this particular 45. So we are loading the same 45. After loading this, now what I'm doing is, I'm trying to see this particular T. Okay, what is the T right now we are having? Same, the 12 record. Okay, the 12 I'm trying to change, like initializing into this particular CH. CH is the one of the child record. Okay, here we are adding this particular P as a parent and CH is our child. Okay, two records we are having, parent and child. Now what I'm doing is, using this particular while loop, we are trying to repeating multiple times. So we'll see how it is going to repeat. So P not equals to null. Yes, it is satisfied. And child here, whatever we are checking is P dot write. Okay, P dot write. So what is the P right now we are having? 45. Get in the pen. So 45. 45 dot right side. So this is the R we implemented here. Right side value. What I'm getting is 54. So we'll see. So P dot right basically. So correct. Sorry, 56 here. So I missed this. So this is, we need to add 56 here and we need to add 54. Okay. Anyway, so right side we are getting as a 56 here, and this 56 is not matched with this particular 12. Okay, CH. So this is the child record we are having. So observe, child record we are having as a 12 and P dot right we are getting as a 56, because 45 is our parent. From the parent, the right side value we are having 56. So both are not matched here. Whenever it is not matched here, which record we are inserting, like which record we are trying to return? P. What is the P right now? Parent. So what is the what is the record we are going to return? 45. Getting the point. So we are trying to load, the first record is completed. Now we are trying to load the second record, something like a 45. Okay. So because here we are trying to returning the P. Once we are returning this, now where it will go? The successor is going to set as the next record. The next record we are going to load 45 one. Okay. The last return, whatever the last return we are having, so this one. So it's something like a 12. Getting the point. So this is important here. Basically, this method, what is doing, whatever the next record we are going to get, the next record we are trying to set into this particular line number 1209. Okay, here we are set this particular next. Whenever I'm calling this particular has next, so it is going to return true or not? It will return true, because the next right now we are having one object here. Here, what is the condition we are providing? Next not equals to null. Yes, the next we are having not equals to null only. Okay, so the first record we are printing here. Now you can see, whenever I'm trying to print, the first record is printing, and has next, just now we identified the has next will return true because we inserted the next record. So I'm moving into the same next here. Okay, so next method I'm calling again. So now you can see what is the next record we are having? 45 related. Getting the point. So here we already identified 41, because in the previous code only we loaded and we set into this particular next variable. Now a not equals null and mod count is also not equals to null. Again we need to check about this particular successor, how it is going to give you the next record. because right now we can return this. We are trying to return the e value, so something like 45 will return. For the next iteration, for the next iteration, whatever we are going to get, the value I'm trying to store into this particular variable called next year. Okay, now we are moving into the same method, the successor method we are seeing it. Now, what is the t we are having? What is the t we are passing? 45. Okay, we are passing 45. After passing this, now we are checking the t dot right. So 45 dot right, we are having the right side value. Okay, so this is the 45 we are having. Right side we are having the value. Now if you see, this section will give as a true. Getting the pen. So 56. Getting the pen. Based on this particular diagram, you can easily understand this is the parent right now. The right side value we are trying to load 56. Okay, so it is matching it. So once it is matching, now what we are doing is we are trying to load, like we are trying to move inside this particular code, and we load the right side value. Now we are making as a parent. Okay, now we are making as a parent. So now what is the P? P is contained 56. Getting the point. Now P is containing 56. Where is this P? Yeah, now you can see. No. P is containing 56.78 here. Okay. Again, we are repeating the loads. Okay, we are trying to repeating this. So this is the one loop we are providing while loop here. So P dot left. P dot left. What is the P dot left here? We are inside the 56. Now 56 is the parent. Okay. So we moved from the 45 to 56. So 56 left side. What is the left side we are having? Null. Left side we are having null. Now you can see, if I'm going to see this, if I'm going to see this particular P dot left, what is the value we are getting? Oh, sorry. So I forget to initialize. Like, I hope right side maybe we are having null. The left side we are having some value. Okay. Anyway, so this 54, now it is replaced with this particular left side. So the right side we are going to have, I hope, null here. So it's like the diagram, I missed this. Now you can see if I'm going to make null here. Now we'll see where is this P only, right? Here I'm going to give the expression. We'll write here P dot right. Okay. So if I'm going to print this, here you can see inside the diagram. So I'm trying to highlighting this section, P dot right. Okay, the P dot right we are having null. So here you can see I'm trying to repeating multiple time this circle here. This value it is giving as a null here. Right side value is null, but left side value we are having 54. Now finally, what you understand here, from this particular 56 parent, again we are trying to load the left side value. Now what you understand here, every the parent record, if it is left side is a like a less value, like a smallest value, and the right side will store as a biggest value. Getting the point? So this is the structure is following internally the tree map here. This is very important here. Now observe. So here the P while loop is satisfying the condition. Now P dot left. P dot left basically 54. So again one more time it is repeating. So 54 cannot have any left or right. Now you can see null we are getting. So 54 is a parent record. So P is nothing but parent record here. Getting the point? Now you can see we are returning 54. But what is the value we are going to get whenever we are calling the next? We'll get 45. For the next iteration, the 54 value we are setting. So carefully observe. P is returning. The successor, now it is returning this particular next. What is the value? Something like 54. Okay, here why it is moving? Now you can see 54. Okay, so next record we are going to get as a 54. So whenever we are trying to returning this, the has next method it will return as a true, and this particular the value current value we are printing as a 45. So whenever I'm calling the has next, it will return true because just now we loaded the value, the 54 value. Now because of that, the has next is returning true. Okay, finally, now again I'm calling the next method. So again next entry I'm calling. Now next record. So here we are going to load as a 54. So here we are trying to load only 54. Now this value we are going to return but using this particular successor, we are trying to load the one more value for the next iterations. Now you can see, though both conditions are not satisfied, the successor we are calling, and t is also not null, and t dot right side. So this particular t, what is the t right now? 54. So if you see the t, it is trying to return as a 54. So if I'm trying to see t dot right, nothing is there. Nothing. Because left and right, we are having null values. Left and right, we are having null values. Okay. So finally, this else if condition will not satisfy. Now I'm moving into the else section. Okay. T dot parent. So right now we are at 54. Now it will move on to the 56 here. Now you can see T dot parent. So again we are coming back to the 56. So we are finally loading the 56 record. So observe carefully, 54 is completed now. The 54 is completed. Again we are going back to the 56. Getting the point. So first this is the parent record, and later this is the parent record, and later this is the parent record, and finally this is the parent record. Now what I'm doing is I'm coming back to the same format. So from here to it is moving on to the 56. Okay, 56 right now, it does not contain any the left or right side value. Okay, we'll see the parent record we are loading. Now we are at this particular 56 here. And what is the child record we are having? Something like a 54. 54 we are having. The child, the CH we are having 54. So finally, P is not equals to null, and CH is not equals to match with this particular right condition. Okay, because right now we are having null here. The P dot right we are having null, and this null is not equals to with this particular CH. So while loop is stopping here. While loop is stopping. So what we are returning here? We are trying to return the 56 here. Getting the point? We are returning this particular 56 here. So now observe, after returning this particular 56, so it is going to reuse for the next iteration. So right now we are printing as a this 45 or 54 value. Okay, 54 value we are returning this. So this is very important to the iterator we implemented internally inside the tree map. Now we are trying to discussing. So next method. So far we printed three records. So 12, 45 and 54. So finally I'm calling the one more time has next. The has next basically, you know, okay. Observe here again I'm calling the same next method. Whenever I'm calling this particular next method, now you can see next entry we are calling and next node. So what is the next value we are loading? 56 here. Okay, 56. After this, so these two conditions not going to satisfy. We are calling the same, the successor. But what is the value we are passing? 56 we are passing. So this is important here. Now you can see the T, it will contain 56 here. Okay, we could not understand here because inside the this diagram, T dot right side. Okay, we are at 56. The 56 cannot have any values right side. Now we are getting as a null. Okay, we are getting as a null. So what happens internally? Else section which will go. Else section. So we'll see what is the else section. So else section, we are going back to the parent record, something like 45. Okay, something like 45. So this is the parent record we are loading. This is important. After loading this, now what is the child record we are having? The child we are having 56 here. Okay, now you can see P parent is not null and child. So if the parent right side, whatever we are having this particular parent to right side. So this is the parent right now 45. The parent right side, what is the value we are having? Something like 56 here. Getting the point. So 56. So now this loop is matching. This loop is matching here. Now whenever it is matching, now so child is a parent now. Child is a parent. So something like 45 is our parent. After this, P dot parent. After this, whatever we are having P dot parent, now we are coming back to the 89. So observe, first we are checking the 56 and from the 56 we are going back to the 45. From the 45 we are trying to move on to the 89. Okay, 89. So finally we are trying to check about the this particular P. So P containing 89 related information. After this we are repeating. So P not equals to null, and child, what is the child we are having? Something like 56. So P dot write. P dot write we are having 96 here. Okay, P dot write we are having 96 here. So this is not matching. So whenever it is not matching, we are trying to returning the P. So finally we are returning 89. So next iteration we are going to print this particular 89 value. Okay, so this is 56 we are printing. Now we are going to print this particular 89, but we need to understand the what is the next value we are going to get. Okay, still we are passing the same 56, 89. Now you can see T dot right. So T dot right side we are having some value that is called 96 here. 96. So finally we are at this particular position. We are at this particular 89 position. Now we are checking this particular right side value. Okay. Now we are checking this particular right side value. The value, it's not equals to null. Condition is satisfied. Now we are moving into this T dot right. We are loading the 96 value, and the left, getting the 96 cannot have any left elements here. Now if I'm going to see, left is null. Only right side values we are having, because 96 is having some greater than value, something like 1 2 3. Because of that it is stored in the right side value. So left is not null value we are getting. So this particular loop is not going to repeat, and we are trying to returning this P. How we are getting this particular P? We are getting T dot right, something like 96 here. 96. Now you can see we are trying to returning this particular E containing the 86 something 89 value. Okay, 89 we are printing here. Now you can see 89 we are printing. For the next iteration we stored as a 96 value. Okay, now I'm trying to call the same method. Next method we are calling, and the successor method we are calling. What we are passing here? 96 we are passing. Okay, 96 we are passing. Now after this, again we are calling this method. So T is not equals to null, T dot write. So the T dot write, what is the value we are having? 1 2 3 something. Yeah, 1 2 3 dot 63. So whenever we are having 1 2 3 dot 63, what we can understand here, we are loading the right side value. 1 2 3 cannot have left and right side value. So we are returning the particular P. Now we'll return as a 96. For the next iteration, we are going to make as a 1 2 3. Okay, so now you can see 96 value it is returning, and finally we are returning the last record, something like 1 2 3, and we need to understand for this particular last record what we are going to do. Okay, so successor I'm calling with help of this particular 1 2 3. So now you can see T dot write. So T dot write cannot have any value. Now we are going to check else section. So T dot parent. T dot parent again, it will come back to the 96 here. So we are loading this particular 96. So child record. So what is the child record we are having? Parent is a 96. Child is a 1 2 3. Okay. Child is 1 2 3. Now child equals to P dot write. So now it is matching the condition. Getting the pen, it is matching. What is the parent we are having? 96. The parent dot write, if I'm going to expand this 1 to 3. So both conditions are satisfied. Now, so child and parent is modifying. Now the child record will be 96. So P dot parent. From this particular 96, again we are calling the parent record something like 89 here. So 89 we are getting. Okay, finally we are returning this particular 89. One more time it is calling. So parent is not matched 89 record. The child 196 we are having. So now you can see P dot write here. P dot write. So parent dot write. Parent dot write. What is the parent right now? 89. Parent is a 89 right now. Okay, parent dot write. So parent dot write something like a 96 only. So it is matching. So again this condition is matching. Okay, again this condition is matching. Now What I'm doing here? So P. So child also I'm trying to modify with the parent, something like 89. So 89 dot parent. What we are going to have? Something like null. Because 89 is the root root element. Okay, 89 is only the root element. So now for this 89, we don't have any parent. Now I'm trying to store as a this. So finally, what is the P I'm returning? Null. Getting the point? So finally, I'm trying to returning this particular null. For the last record, we are going to return as a null. Whenever we are returning this particular null, the next it is going to store as a null. And here, null not equals to null. Null not equals to null. What happens internally? It will return false. So whenever I'm trying to call the has next, what happens internally? It will return false here. So if you see, it will not execute the line number 19. Okay, it will move on to the line number 20 here. Line number 20. Now you can see line number 20 we are executing. So again this is same TS. So this particular println internally, again it will go for the same iterator, and again it will call the key iterator next and has next method. But how it is executing internally, the diagram. So here again we are calling this. So I will move on to this. The diagram is going to give the information. Whatever the diagram we define this diagram will give you the more understanding of this particular tree map, or we can call it as a tree set, because we are discussing about the set related example. We can identify the tree set. So any questions how this iterator is working internally? We identify the line by line execution. So anyone having any question? Okay.
Sir, I missed that part when you explained how is 89 fixed as the root, sir. 85 or
Okay.
89.
Yeah. I will explain one more time this particular diagram, how it is created internally. Now if you see, here we are having the records we are trying to inserting into the tree set. So while calling this particular add method, we are trying to creating the diagram, whatever we discussed so far. I will start from the basics. We'll see how it is created internally. Now, if you call this add method, we'll first identify the how this add method is calling internally. So this is the double one. Again, I'm calling the add method. We are calling map here. So what is the map? Tree map. So tree map dot put method we are calling, and we are passing the two parameters. First one is the element. Second one we are passing present. So this particular present every time will pass as a same. Now, if I'm going to check this particular map dot like a tree map dot put method, how it is working internally, we are trying to check this particular root node here. So now you can see, so far this particular root is null because this is the first record we are inserting. Okay, this is the first record we are inserting. Now you can see here the root node is null here. Okay, once it is null, we are calling this part here. We are trying to call this part here 465 470. Sai, I missed your line number. Okay, I will come back to your line numbers. We'll see how it is implemented there. But try to understand this. So T is null. So whenever this particular T is null, now what I'm doing here, I'm calling this particular compare method by passing the same key twice here. So now you can see first parameter I'm passing the same key. Second parameter also I'm passing same key. So just but it will return some value even though the value we are not using anywhere. Now you can see now internally what is the value it is returning? 0, because both values are same here. And after this, now what I'm doing here, I'm trying to create a one entry record. We discuss this particular entry record will contain this particular key and will contain the value and will contain the parent. Along with this, so it is going to have left side and right side also. Now if I'm going to explain this entry, now you can see key containing value, left side one entry record, right side one entry record, and parent and parent. So these are all the variables we are having. So key, value, parent, left side, right side here. These are all the the same, the variable we declare inside this particular entry class. So these three are only we are using so far, the left and right and parent information. So back to here, we'll go back to the same wherever we are right now. We are creating the entry record and I am trying to pass parent as a null. Key I'm passing, value I'm passing. So parent I'm not passing anything right now. It is null. So because it is a root record, first record. So root we created. So what is the root we created? 45. Now if you go to this, what we are passing here? 45.12. With help of this particular 45.12, we created the root record. After this, we are increasing the size and we are returning null. And whenever I'm trying to returning null, because the add method is a boolean type, we are checking this expression is returning null and we are checking double equal to operator, null equals to null. So both are matching here. Both are matching so that it is returning true. So first record is completed. Now we are moving into the second record. Whenever we are moving into the second record, again I'm calling the same, the add method internally, the put method is calling internally. So right now we are checking the root. So the root will contain this particular value 45.12 because so first record we created as a root record. Now this condition will not satisfy now because T is containing some records here. Okay, whenever the 535 condition will not satisfy, now we are moving into this. So comparator. So comparator so far we did not implement it, because of that it will give you the null here. Okay, this is null. After this, so this condition will fail here because CPR not equals to null we are providing, but this condition will made as a null. Okay, so if condition is fail, now we are moving into the else condition. So key it is not null because we are providing 89 here. So 89 we are providing here. After this, we are checking the comparable. What is the key? Okay, so what is the key we are having? The key we are having right now something like 89.41. Okay, second record we are trying to get as a K. And after this, what is the T we are having? T, it will contain this value, 45 value. Now what I'm doing here, I'm trying to set as a parent. Now this particular parent, now it is going to modify with 45 value. Okay, so observe carefully, parent we are having so far 45. We are checking this. So T dot key basically it will return the 45 value. Okay, and what is the K we are having? Something like 89 here. 89 because the second record we are passing as a 89 and the first record we passed as a 45. So 45 is a less value compared to this particular 89. Now what is the value we are getting it? CMP. Now you can see 1 we are getting. 1 we are getting because positive value. So whenever we are getting the positive value, we are storing in the right side sections. Whenever we are getting some negative value, we are trying to store in the left side sections here. Okay, now if you see, this is the CMP we are getting positive value. So this condition will not satisfy. This condition will satisfy. So T dot right. What is the T right now? 45. Okay, so here you can see T will contain the 45. Now I'm trying to set as a right side here. So T dot right. Whenever I'm trying to set this T dot right here, now what happening internally? Getting the pen. So what happening internally? This is so far the diagram I will give you root. Getting the pen. So this 45 we are having root. Getting the pen. The 45 will containing the right side value and the same way will contain the left side value. So right side, what is the value we are inserting right now? Something like 89. Okay, left side we are not inserting anything right now. So observe carefully. So this is the right side value we are inserting into this particular T. Okay, what is the right side value we are going to get first? Null. First we are checking the value, null value we are getting. The null I am trying to set into this particular T. So if you see, so we set it, and if this particular T not equals to null, this particular loop will repeat. So this is the code is going to repeat it multiple times. But so far, whatever the T we are having, this particular T null we are getting. Whenever we are getting this particular null, this line, it is not going to repeat multiple times, only one time. Okay, so we are coming back to the while loop. Now, one more record we are creating. One more record we are creating. So what is the parent so far? 45. Getting the point? So parent. So parent is nothing but root here. So far this is only the root we are having. Right. So after this, the key we are passing, value we are passing. What is the key we are passing? Something like 89. Now, after creating this particular record, again we are checking here. This is important here. This is important here. Again we are checking this particular CMP. So CMP here we are checking, and same way here also we are checking. So here we are trying to initializing the information, and here we are trying to load the information. So using the same CMP variable. Okay. So if it is less than 0, it will set as a left. But right now it is the CMP is a positive value. 1 we are getting. Okay, it is a positive value. So that it is trying to set as a right side. So this is the parent dot right. Parent is a 45. Now we are setting the right side value something like 89. Now this is the right side we are setting. Okay, this is we are setting. So after setting this, now I'm not doing anything. The fix after insertion, we are increasing the size plus mod count. Okay, after that we are returning the null. Condition will satisfy. We are going back to the same add method. So this is the third record I'm trying to insert. Whenever I'm trying to insert this particular third record, this is the root is going to modify now. So this is the root is going to modify now. Now if you see, again I am calling this particular 96 value. So what is the root so far? What is the root so far? 45. Okay. Now the same 45 only root element. So T it is not null. We are going to check with this comparator null, and we are coming back to the else section. K is not null, comparable. What is the K value? What is the K value? 96 something. Now you can see here 96.74 is the K. Okay. And what is the T value we are getting? So T right now we are getting as a 45. So this particular T now I'm trying to set as a parent. Now I'm trying to set as a parent. So T and parent as of now both are same. Okay. And this is important. K value we are getting as a 96, and T value we are getting as a something like a 45. So if I'm going to explain this 45 we are having, here we are using the compare to method. Now this value is the bigger value. Again, now if you see, same the positive value we are going to get. Now positive value we are getting. So when we are getting the positive value, this condition will not satisfy. So we'll try to load this particular section. Okay, whenever I'm trying to load this, so T dot write. T dot right. So what is the T? T is the root here. T dot right. We are having 89. Now if you see T dot right will return as a 89. So 89 records is loading. Now after loading this loop is going to repeat one more time. So one more time this loop is repeating. Once it is repeated, now parent is replacing here. Now the parent is replacing here. Now if you see, parent will become 89. Parent will become 89 here. So earlier the parent we are having as a 40, 45. Now it is replaced with something like a 89. Again we are checking 96 and here 89. So again we are going to get as a positive value. So now you can see again 1 we are going to get. After this we are trying to check the same right side value. So far for this particular 89 we don't have any right side value. Now it will return as a null. Now it will return as a null. Now you can see, now if I'm going to load T dot right, it will be null here. So whenever it is null, this particular while loop, it is going to stop here. It is going to stop. So now what you need to understand, what is the parent right now? 89 is the parent. With help of this particular parent, we are trying to create a one entry record here. The 96 will come under the 89, not under the 45, because of this particular do while loop. It is replacing the root node here. Okay. So after this, we are checking this particular CMP. Again, this condition will not satisfy. We are trying to store parent dot right side E. Okay. Here, so this particular value is replaced with 96 here. 96 is replayed because parent dot right side we are calling. What is the so for parent? This 89 is the parent. Okay. Now parent dot right we are having the e value. After this size we are increasing count. Getting the point. Now if I'm going to come back to this 56, 56. Now if you see what happening internally, so I'm calling the put method. I'm calling this particular root here. What is the root we are having? 89. Why we are getting the 89? Because in the last example, so the 45 now it is replaced with this particular 89. Getting the point? Because of this 89 is the root node. Okay, 89 is a root node. Now you can see comparator. So again we are checking. Now key. So what is the key we are passing? Something like 56 I hope. Yeah, 56 we are passing. And t dot key. What is the t dot key? 89. So it is a less value. Now we'll get as a negative value. Now you can see -1 something we are going to get. So -1 we are getting. Whenever we are getting the -1, so this condition is satisfying. We are loading the value t dot left. What is the value we are getting here? T dot left basically it will return as a 45 will return. Sorry, null. Okay, for this 89. Okay, so far it is written as a right side record only. So 45 t dot left still it is returning null. The loop is stopping here. Uh, oh, sorry, t is replaced here. Yes. So basically the parent is now 45. Yeah. Basically it is loaded this particular 45 value. After that I'm loading. For this particular 45 we don't have any record. So because of that it is written null. But correct. So two times this loop is repeating here also. 45. 45, the key dot t dot key we are going to get as a 45 and we are having k value 56. So we'll get positive value. Getting the point. So positive value we are getting. So t dot right. T dot right is null. T dot right is null. Getting the point. Now we are creating the parent. So parent is now again modifying here. Parent is now 45. Parent is again come back to the 45. Okay, after this we are creating the node and we are setting to right side. So if you see this is the root right now. Again we are having left and right. Here I am trying to set 56 as a right side, and for this left side still null values we are having. Okay, this is the way of this is a way of setting the value inside this particular entry record. So again, it's going to take some time to insert this particular value. So is it clear? Any questions here? So how it is calling internally to set the one by one value. So you need to debug the code, the like tree map dot put method, how it is inserting the data. This is one of the important example we need to understand here. Okay. So any questions?
No, sir. Thank you. Thank you so much.
Okay, so I'm trying to stop this particular uh, debug mode. Now we'll identify. Uh, yes, I am coming back to the your line number. We'll go to the tree map. What you suggested, 465. Where is the 465? Something like here only. Okay, this is what I'm doing here. 465, 465 to 470. So it is between this code. Okay, let me, anyway, I'm going to explain this. So 465, I think this is wrong. We are not calling this particular higher entry method. We are not calling this particular higher entry method. Most probably floor entry, ceiling entry, get entry, where we have, I will go to next method inside the key iterator. So this is the method we discussed so far, and inside the successor we discuss these are all the method. But I don't know, so you are giving the different the 465 is the line number is different here. So which line number you're talking about, Sai? Because the 465 we did not discuss here. So whatever I'm highlighting here, this is the code we discuss here. In the tree set also 465, it is different, I hope. No, no. These are all the different method. It's showing the line number, but I don't know. The 465 something it is different, but most probably we discuss on this particular entry set here. Sorry, yeah, entry record we identified, and later we'll move on to the iterator related method. So if you check this video, like still if you're having any questions, you can ask me in the tomorrow session. Okay, come back to here. What we need to understand the remaining method. So far, I'm trying to comment on this particular iterator related method. Now I will call this so ts dot add all method. Getting the point. So here I'm going to call this particular add all method, and to call this add all method, first I will try to insert the one record. So here I'm going to insert something like linked list. Now here I'm going to use the same string because we cannot use another generic type here. Internally we are having the wildcard condition here. Okay, linked list I'm calling, and ll dot something like add method I'm going to call. What are the values? So sorry, it is expecting double, not string. We need to modify with the double. Okay, something. So 10 dot 45 I'm adding it, and ll dot add method I'm going to add something 75 dot 23. Okay, ll dot one more add method I'm going to call, so 96 dot 52. Okay, these are all the three records. So we can add any number of records here, but for the current example, I'm adding only three records. So here I will pause this particular LL. Okay, I'm going to pause this particular LL. So we are trying to discuss about the add all method, how it is implemented internally. Now, if I'm going to show you this, so what we are doing basically, we are trying to load this particular M. Okay, M, I think here we implemented. Okay, navigable map. Yeah. So anyway, now you can see M we are having it. Because of this particular M, we are trying to load the size, and if the size is greater than or equal to 0, and if this particular C instance of this particular sorted set, and if the M is instance of this particular tree map. These are all the conditions we are having. Okay, these are all the conditions we are having. After this, now what I'm doing is I'm trying to converting this particular C into this particular sorted set here. Okay, it is one of the generic type we are using here. We are trying to converting into the sorted set. After this, the M we are trying to converting into the map, tree map. And here I'm calling the set dot comparator. Set dot comparator. So far, the comparator we did not implement it here. We'll see how it is going to add the records here. So I'm trying to put a breakpoint here, and I'm going to run this example in the debug mode, so that we'll understand how this add all method is going to work internally. Now I'm calling this add methods we identified. Now finally I'm calling this add all method. So let me go to inside this. So this is the C we are passing. It is containing the linked list and double value. M dot size. So far M dot size, how many values we inserted here? Navigable map, it is not returning here. Okay, so I will add one expression here. We'll see how this expression will work or not. M dot size method I'm calling. Size error during the evaluation. Maybe because of this we are getting an error. So I think easily we can call this. I don't know. Okay, anyway, so 0 to 6 we are getting 7 record. So 7 record. The size we are having 7, and it is not going to match with this particular 0. So if it is not matching, we don't need to check other condition, because all the other condition they are using AND operator. AND operator basically all the conditions should satisfy. Okay, all the conditions should satisfy here, but here all the conditions are not satisfying. If it is not satisfying it, simply it is calling support dot add all. We'll see how it is implemented. Now you can see this entire section is failed. Entire section is failed. Now we are calling the support dot add all. So what is a super basically? What is a super? Tree set internally, it is extending from the abstract set here. Okay, it will call the abstract collection. So directly it is moving on to the abstract collection. This add all method is not yet implemented under the abstract set. So directly it is coming back to the abstract collection. So finally what we are doing is we are trying to repeat the loop here. So again we are calling the same add method. Again we are calling the same add method. So whatever we discussed so far, the same code is going to implement one more time. Okay, one more time. Whatever we discussed, the left to right to the compared method, what we identified, same code is going to execute, and it will try to add the, like it will try to insert the new entry records. Okay, this is we need to understand here. So I'm not going to debug one more time for this particular add all method. Okay, we are having 3 records. So now you can see it is modified. Finally, it is trying to return the true. So this is the add all method. Okay, add all method internally, again it is calling the add method with help of for each loop. So one by one, again it is going to call. Now if I'm trying to print this, so now you can see the values are modified here. The values are modified. But first to record what we are getting, 10. 10 is the smallest value, 120 is the biggest value. But earlier, 12 we print here, now we are trying to print this particular 10. Getting the point? So 10, 12, 45, 54, 56, 75, 89, 96. So 96, 52.74. So these are all the true records we are getting. Because of this particular comparator, internally we are getting the sorting behavior. Getting the point? This is the add all method we identified. Okay. After this, what all the remaining method we are having? Let me go back to here. So inside the collection framework, I'm trying to open this file. And this tree set will give you the more information because internally it is extending multiple classes here. Now if you see this, the tree set internally it is extending this particular abstract set and it is trying to implementing navigable set. So we need to discuss about the where is this list. First we need to discuss about this particular set, and later we need to discuss about this particular sorted set, and later we need to discuss about this particular navigable set. These are all the different methods we have inside this particular interfaces. We need to discuss all the methods so that we can easily understand how the tree set is implemented internally. Okay, so anyway we'll focus first on the set related method. Set related method. So size method we identified, isEmpty method we identified, iterator we identified. So this two array. So what exactly this two array will do? I will copy this particular two array and we'll try to print this. After calling this add all, here I'm going to call ts dos. Ts is basically tree set. Two array I'm calling it. Whenever I'm trying to call this particular two array, first we'll see the internal implementation. How it is implementing based on the size. Now if you see, if you observe carefully, this is implemented the two array inside the abstract collection, not inside the tree set. Getting the point? Now simply we can call, again we are calling the iterator, again we are checking the has next here, again we are trying to load the next here. Same thing. Getting the point? So two array also internally, it is calling the iterator, has next method and next method. Whatever the next method is trying to return the value, the return value we are trying to store into this particular R of I. R is a object array. Okay, R is a this particular object array. Getting the point? So far we discussed the iterator, how it is implementing. So try to practice this particular two array, how it is going to implement inside this. Okay, now we identified this. So finally the two array will return this particular object here. Now I am going to print this particular object using this particular for each loop. Okay, This is I'm going to print. After this, I will comment out this. No need to print the multiple records here. Now you can see. So 41. Otherwise, we can put as a comma. This will give you the more understanding. 40 like 10.41 is the first record, 12 is the second record, 45 is the third record, same. So whatever we identified up to the 123. But how it is getting internally, we are calling on the iterator. The iterator internally, it is calling on the has next and next method. Okay, so this is the two array, and the second one also same. Whatever we are going to pass, this it will try to repeat. So this is no need to check this, because here we are providing the type array, the same type array it will return. Getting the point? So if your time, you can check this type array, you can pass any array like integer, string, something, and it will try to return the same type here. But only it will get as a array type values we are going to insert, same array type we are going to get here. Okay, no need to check this. So add method, and after this we need to understand the remove method. Okay, so remove also one of the important method. Getting the point? How we are inserting the element into the tree side. The same way we need to focus more onto the this particular remove method. How it is going to remove the object from this particular tree set here. So what is an object I'm trying to remove? Something like 1 to 3. The last record I want to remove 123.63. So that it will try to remove multiple times. Sorry, this is not available, not a string here. We need to insert as a double value. Okay, now I will call this remove method. How it is going to implement internally. Directly I am coming back to this remove method. Okay, idle we have, no need to check this. So remove method. Okay, so we are trying to focus on the remove method. Now observe carefully, I am calling this remove method, and after remove we are calling m dot remove. M basically tree map. So tree map dot remove method we are calling, and internally get entry. This is important. This method is very important. Get to entry. How we are loading the entry record. Okay. So here I'm passing this particular 123 value. Getting the point. I'm trying to load the entry record. Now if you observe how it is implemented this. First we are checking the comparator. So comparator is null. Okay, so key is not a null. Now we are trying to converting into comparable. So what is the key we are passing? 123.63 we are passing. And what is the root we are having? 89. Okay, 89 is our root record. So finally, from this particular root, now I'm going to repeat while loop here. Now see, this is the while loop. It is going to repeat multiple times. So now observe P. P is the our root record. Getting the point? P is our root record. Now what we need to understand here, if I'm going to show you this 89, I'm getting it. After this record is not equals to null. So condition is satisfying. Again we are trying to compare the value. So what is the K? The K we given as a 123. Getting the point? The K we given as a 123, and P dot key. What is the value we are getting? Something like 89. Okay, something like 89. After this we are trying to call the one of the important method called compare to. So positive value we are going to get, we are getting the one value. Once we are getting this particular one value, I'm trying to load right side value. Now you can see what is the right side. The right side, I hope we are going to get as a 96 here. Okay, 96 we are getting. Now the parent is the P. Now it is replaced with the 96. So still we are going to get positive value here. The K we are having 123, and this particular P dot key we are going to load as a 96 here. After this, again we are going to get as a positive value. Okay. After this, again we are trying to load the P dot right. What is the P dot right we are having? 123. Okay. So finally, we are trying to load the whatever the entry record we are having, P dot right. So this is the P dot right. Right now, P is also not equals to null. Now the CMP will return 0. This particular CMP will return 0. Why it will return 0? Both the keys are same. So now you can see 0 it is returning. It is returning 0, and once it is returning 0, if condition will fail, else condition will fail, and else if will fail, and finally we are checking on this particular else, simply returning P. Getting the point? So finally we identify the node here. Getting the point? Finally we identify the node, the P we are returning. Getting the point? So this is the P we are going to have, something like 123.63. Based on the key, we loaded the object. After this, now what I am doing here, I am trying to load P dot value. What is the value we are having? Present. Okay, the object reference. And after this, I'm trying to call the delete entry. So I'm trying to delete this particular entry. After loading the based on the key, I'm going to delete. So how we are trying to delete this? Mod count we are making, size we are trying to decreasing here, P dot left. Okay, whatever the P dot left. What is the P basically? Right now is P is a 123 dot some 23 values. P dot left we don't have value. So I'm thinking we don't have. So I think it's correct. Okay, it's null. And what about this particular P dot right? The right side also we don't have. Right side also we don't have this particular value. Now you can see both left and right we are having null. This condition will not satisfy. Coming back to this. Okay, so here P dot left not equals to null. If the P dot left to not equals to null, so it will call this, otherwise P dot right. So both cases it is replacement be null. Getting the point? This particular replacement be null here. After this, we are calling this condition will fail. After this, we are checking this particular else. Okay, else if we are checking. So this is the else if also not no, this condition again will fail, because P dot parent we are going to have 96 record. 96 record. But what we are doing is we are trying to checking the null. So this condition also not satisfied. Finally, we are checking this. So this is will give you the deletion about the node. Okay. So P dot color. The color we are having something what we are having. I think we could not check this color earlier. What is the color? Oh, P dot color false we are getting. Okay, anyway, we could not understand the what is the color. So anyway, this particular condition is not satisfied. Now, what we need to check this? What we need to check this? So if you see P dot parent not equals to null, it is trying to load this. The P dot parent, it is not a null. Hmm. Okay, P dot parent basically it is a not null. Now what I'm doing it? So we are coming back to the one more if. So you can see P dot parent dot left. So 96 having any left records here? No, we don't have any left records. Okay, sorry. What happens internally? If you see this, we are getting 96. How I'm trying to load? P dot. What is the P basically? 96 is wrong basically. Okay, 126. Yeah, got it. So because of this, we are getting on the 96. So P basically it is trying to return as a 123. Because of that, we are getting as a 96 here. Okay, 96. Now we are trying to replace with this particular P. Okay, so after this, what we are doing is, this left value, it is not equals to match with this particular P. Because of that, we are trying to check on this particular else if. So what is the right side we are having? Right side also something 123. Now if you see P dot parent is a 96. Okay, for the 96, 1 2 3 same. So both are satisfying here. Now whenever it is satisfied, we are making as a null. Whenever it is satisfied, we are making as a null. The P dot parent dot right side is null. After this P dot parent also we are making null. Okay, this is important because here the P dot parent basically 1 2 3. The P dot parent 96 we are making as a null here. So this is a way of deleting the one of the record from this particular tree set here. Now you can see there is no 1 2 3 record. So 96 52, 96 74. Up to this we are having the all the records here. So this record is removed. To remove this first, what we are doing is, based on this particular ID, now we are trying to find out the entry record. Once the entry record is identified based on the parent left and right, we are trying to delete the node information. Okay, so this is important, we need to understand here. Okay, these are all about the important information regarding this particular tree set. So we'll continue the tomorrow. We'll try to discuss about the some contains all method, remove all method, retain all. Once we familiar this set method, we'll move on to the sorted set. Okay, sorted set and another one, navigable set. We'll try to continue this session in the tomorrow morning. We'll most probably will close up this particular tree set tomorrow. Okay, so any questions regarding the today's session, what we discussed here, the tree set related? Anyone having any question?
No, sir. Hi, I am new to Java and I joined in the middle of the training, so I am unable to get the training. So I wanted someone personal training. If anyone can help me out, please in the group, let me know.
Okay, just message me in the WhatsApp. I will let you know what we can do.
Can I get the WhatsApp number, please?
Where you got this link?
Sam sent me this link.
Sam.
From the group. I got it from the group Extract Java
Okay, no
training.
problem. So you can ask them the same the WhatsApp number they will give you.
Okay. All right. Thank
Okay.
you, sir.
Okay. Any other questions?
Hi, this is Sandhya here. Even I am new for the Java. I am also looking for the starting classes. Is there any immediate class?
Right now, so we don't have any batch. So this is because we are close to this core Java. Okay, I will
Okay.
give you the recorded session, so you can go through the recorded session. And in the daily, like if you attend the daily session, you can ask me whatever you're having the queries regarding the core Java. I will come back and I will let you know.
Yeah, that would be helpful. And can I share the email to this link, or should I need to share the
Just message me in the WhatsApp. I will give you the all the details.
Okay, yeah, that will be helpful. Thank you.
Okay. So any other questions?
Sir, are you the group admin in the WhatsApp group? Like
I
there
don't know which
are.
group we are talking about, but I'm
It
not
is
the group admin.
okay. You are not the group admin. So I'm calling from Chicago. I'm from talking from Chicago. So if you can give me, I'll ask Sam to give
So
your
just check
number.
with your friend and message me in the WhatsApp.
Okay.
That is fine.
Okay.
Okay.
Thank you, sir.
Uh,
Thank you.
okay. I hope we don't have any questions. So we'll continue tomorrow the same time, like 7 to 8:30. So join the session. So these are all the most important the sessions we are discussing here. Okay. So we'll continue tomorrow.
Yeah, thank you.
Thank you, sir.
So thank you all.